Okay, so again, right at the very beginning of this chapter, it was the whole idea about what's a point, what's a line, what's collinear. So point, simply a location, okay? It's a location in space. If they asked you for an example of a point, point A, there's your example. A line is made up of points and it's named by two endpoints. So this would be an example of a line. And let's say that's ST. Okay, that's a line. This is my abbreviation for a line. Collinear means points on the same line. So let me say I threw W in here. S, W, and T are collinear. They're all on the same line. Obviously, if it says non-collinear, it means not on the same line. So A is non-collinear with S, W, and T. A plane is a flat surface made up of points. It is named by a cursive letter. Okay, so if I'm talking about this plane that's my board, I could put a cursive Y down here and go, this is plane Y. I would abbreviate it like that. Okay. It can also be named by three non-collinear points. So now they have to be non-collinear. That doesn't mean, obviously any two are collinear, but the third one would make it not. So if I want to talk about this board, which is the same as plane Y, I'm talking about plane SWA, because A is non-collinear. So I can use these 2 points in that one. I could use those 2 points in this one. I could use this one, and this one. Okay, just as long as not all three of them are on the same line. Any 2 points have to be on the same line. It's when you throw the third one in that you know that they're non-collinear, okay? There's an example there on page 1 that shows you that plane. Okay, coplanar means on the same plane. So non-coplanar would mean on different planes, okay? On this board right here, S and A are coplanar points. If I put a point out here, then that point out here is non-coplanar with that, all right? Then it says at the very bottom of that first page and at the top of the first page, it says, make sure you can identify the above items off of an illustration. And it says, no definitions, be able to draw examples. Okay, very clear, very clear. Okay, if you turn the page, and what we're going to do is we're going to go through the study guide, then I'm going to come back, I'm going to turn off the camera, then I'm going to come back and have you do some examples for me, okay? Section 1, 2, be able to precisely measure using centimeters or inches. So if I gave you a line, you would have to use a protractor or a ruler to be able to measure that line. I don't think that's any problem. I wouldn't think it would be. The other thing that we talked about in this section was precision. Now that's the only thing that might trip you up a little bit. And I don't even think that there's any on the review at the end that I'm going to give you. I don't think there's any like this. So make sure you pay attention because it is on the test. If I have something that measures 12 inches, remember how we talked about the fact that a ruler can be like chewed up at the end or it can have gunk added to it. So we go, what is that precise to? What is the precision of this? So what I do is I go one place past where I am. So in this case, I'm going to the tenths place and I take half of it. So I'm going to add decimal 5 to everything and I'm going to subtract decimal 5. So the precision of this is going to be from 11.5, which is what I get when I subtract 0.5, to 12.5, which is what I'm going to get when I add 0.5. So I'm subtracting 0.5 from that, I'm adding 0.5 to it. If I turned around and I said, well, this is 12.4. Now what I'm adding to it is 0.05, and that's what I'm also taking away from it, okay? because I put a place value right here, I put a 0, and then the next spot over, I'm going to take half of, so that's going to be 5. So this is going to be 12.35 to 12.45. Y'all remember all that? Okay. If I had, something like that, then I go, okay, I got to have placeholders for each one of those numbers, and then a 5. That's what I'm adding, that's what I'm taking away. So 7.3455 to 7.34565. Okay? Now, fractions are a little different. Do not convert the fraction to a decimal. You convert the fraction to the decimal, you get the problem wrong. Okay, no partial credit is just wrong. So let's say I have 7/8, and I want to know the precision of 7/8. What I'm going to do is I'm going to take the bottom number and I'm going to double it. So I am going to add and subtract 1/16. Okay, very easy way, but I've got to be able to convert this to a common denominator to be able to do it. So this becomes 14/16. Okay, multiply the top and the bottom by 2. You both with me? Okay, so when I subtract, I get a 13/16. When I add, I get a 15/16. That right there is the precision. Okay? If I have a mixed numeral, I have 2 and, I don't know, 3/4. What I'm going to do is I'm going to go ahead and I'm going to change that to an improper fraction, and then I'll work my way around it. Okay, so, well, I don't even have to do that. Let's do it just with this fraction. What am I going to add and subtract to it? 1/8. Okay, the 1's always going to be on the top. Then I just have to take the bottom number and multiply it by 2. That's the way I do it every time. So I have 1/8, but again, I can't add and subtract a 3/4 because it doesn't have a common denominator. So this needs to become 6/8. So when I subtract, I have a 2 5/8. When I add, I have a 2 7/8. Okay, Debbie, you with me? Okay. That is the first part of page 2. I don't even know that I went all, that you are responsible for that on a test. We also talked about numbers in between other numbers, or letters in between, and how 2 parts together equal a whole. So let's say I have A, B, and C, and this is, I don't know, 2.2, and this whole thing from there to there is 7. How am I going to find that? I'm going to, absolutely. 7 minus 2.2, obviously you can do it on the calculator, but if you do it by hand, you've got 4.8. So this section from here to here is 4.8. So the 2 parts added together is going to equal the whole thing. You're going to have some practice on that on your homework. 2 segments that have the same measurement are called what?
Congruent.
They're called what?
Congruent.
Congruent, okay? They're called congruent. So if I have AB here, and over here I have the exact same measurement, but it's CD, I can say that AB is congruent, which is an equal sign with the little curly Q over the top of it, to CD. Okay? Distance and midpoint formula. Okay, your homework worked a little bit on the distance formula, so let's just take 2 points that we have. Let's say I have 10, 18, and I have -2, 8. Okay, I should be able to take those 2 points and find the distance between those 2 points using my distance formula, and I should be able to find the midpoint between those two using the midpoint formula. So the distance formula, remember, is the difference, and it doesn't matter whether you put the y's first or the x's first, because there is no order to addition. So you might have it done like that, or you might put that first and that second. It really doesn't matter. Notice though, you are going to square the answer. So that's what I was telling you on that quiz. Neither of these can be negative, okay, because you're going to square it. So if I were going to do this problem right here, I would say 18 minus 8 squared plus 10 minus a negative 2. Don't mess up on that. 10 minus a negative 2. So sometimes you've got a double negative, okay, which is going to make it a positive. So this is going to be 10. 10 squared is 100. This is going to be 12, which is going to give me 144 when I square it. So I'm going to take the square root of 244, which is not going to come out even. So it's going to be approximately 15.6 units between those two. Okay, both of you okay with that? Okay, midpoint formula. Remember, the midpoint formula is the average of the x's and the average of the y's. So midpoint x is equal to x of 1 plus x of 2 divided by 2. Midpoint y equals y sub 1 plus y sub 2 divided by 2. So 10 plus negative 2 is going to give me a positive 8 divided by 2 is going to give me a 4. 18 plus 8 divided by 2 is going to give me a 26 divided by 2, which is 13. So my midpoint, the ordered pair that's exactly in the middle of those two, if you did it on a coordinate plane, is the point 413. Okay, you both good on that? Okay, that is all page 3 and page 4. There's an example on the top of page 5 where they give you a midpoint, but they don't give you the other end point. Okay, so we're going to take this, let's do, oh shoot, I shouldn't have done that. Hold on. Let me leave it right here so I don't have to rewrite it. Okay. Let's say that I know that my midpoint, and you got to read the problem real careful to know which is your midpoint when they do this. So let's say I have a midpoint of B, okay, and let's say B is 210. And then I have another endpoint called A, and it's going to be at negative 1, 8. I want to know the other endpoint, which is going to be C, okay? You have to use this to be able to solve this. So what you have here, rather than having both of these, you're going to have this and one of those, this and one of those, okay? So if I plug in here, I've got the midpoint x is 2, so 2 is equal to, and then I have one endpoint, so negative 1 plus x over 2, and then I have to solve that. Down here, I've got the midpoint y, which is 10. I have one of the y's, which is 8, so I have 8 plus y over 2. Now, how do I solve this? What's the first thing I'm going to do?
Multiply both sides by 2.
Multiply both sides by 2. Okay, so I have 4 is equal to negative 1 plus x. Now, how am I going to get that x by itself?
Subtract a negative 1.
Actually, I'm going to add a positive 1. Okay, And so therefore, I'm gonna get x is equal to 5, okay? That's my x value. Okay, then I'm gonna do the same thing down here, multiply by 2, so I have 20 is equal to 8 plus y. Then I'm gonna subtract the 8, so I'm gonna have 12 equals y. So my other endpoint there is 512. Okay? Then you got to section 1.4, which is on page 5 of your study guide, and it talked about angles. Okay, so we began to talk about how you name angles and what angles are made up of, and how angles can be related, which is what we did yesterday. So if I have an angle, it's talking about that space right there. Between those two, these are rays. Okay, so if I name this A, B, C, then I call this angle A, B, C, or angle C, B, A. Your vertex, which is right there where it turns, has to be in the center. Now this particular angle that doesn't have any angles around it could also be called angle B. But if I have another angle right off of it, then I can't do that. Because how do I know what B is? Is it that angle? Is it that angle? Is it the whole angle? So if it can't be misunderstood, you can just name it by the vertex. And then you're always going to put the angle sign in front of it. Okay? Angle, for our purposes, are going to be measured in degrees. Later on, when you get into pre-cal, it's going to be measured in radians. Okay, but for our purposes, they're measured in degrees, and you should be able to measure an angle using a protractor to be able to do this on your test. Remember degrees, like and I'm guessing here, I'm going to guess that that's close to 60 degrees. It has a little degree mark above it to distinguish it. Anytime we're talking about bisecting something, whether it's a segment or an angle, if I said something bisects this angle, it means it cuts it exactly in half. So this would be 30 degrees and that would be 30 degrees. Okay. Interior points, I'm going to get rid of this particular angle again. Like this would be an interior point right there, inside where the angles go out. Anything out here would be exterior point. That should make sense. Interior of a house versus exterior of a house. Okay, a right angle measures 90 degrees. An acute angle is less than 90 degrees. Such a cute little angle. And obtuse angle is greater than 90 degrees. Angle bisector, of course, cuts it exactly in half, like we talked about. On this study guide, it says you should be able to draw this. You don't have to do any of the drawing part of it. Angle relationships. This is what we talked about yesterday. If you have an adjacent angle, what does that mean?
They're right beside each other.
They're right beside each other. They have a common side of their ray, okay? So these would be adjacent angles because they have this ray in common, okay? They have to have a common ray. So we talked about that. There's an example there on the bottom of page 6 of those. Vertical angles, remember, are joined by two intersecting lines. So 1, 2, 3, 4. Name for me, David, a set of vertical angles.
1 and 3.
1 and 3. Okay, hold on, I've got to reset this.